India has one of the largest rail networks in the world but does not have any high-speed rail lines capable of supporting speeds of 200 km/h or more. High-speed corridors have been proposed but not implemented. A standardization body will evaluate different options available and provide a common standard to be implemented across India. HSR is still on the drawing board without any official long-term implementation plan for HSR announced, but first railway lines are expected to become operational between 2030 and 2035. India is currently focusing on high-speed railway track rather than high-speed rail, so that Indian rails can run faster on the current tracks, with a maximum speed at around 160 to 200 km/h. Clocking average of 130 km/h. In the election manifestos for 2014 general election in India, the two major national parties of India, BJP and Incorporated, pledged high-speed rail in the country as part of their manifestos. The Incorporated had pledged to connect all of India's million-plus cities by high-speed rail, whereas BJP, which won the election, has promised to build the Diamond Quadrilateral project, a euro connecting four major cities of India located in four edges of the country, modelled on the completed Golden Quadrilateral Mega Highway project. The project was confirmed as a project of priority for the new government in the President's speech. Current effort to increase speed to 160 to 200 km/h. For the first time in the history of Indian railways, it aims to increase the speed of passenger trains to 160 euro 200 km/h on dedicated conventional tracks. The railway minister said in 2012 that a combination of prudent investment decisions in the areas of track and bridges, signalling, doubling and train sets is proposed to be adopted to enable train running at speed of 160 km/h and above. The proposal would significantly reduce travel time for passenger trains by 20 to 25%. Such infrastructure would also enable railways to run Shatabdi trains on long-distance trunk routes and between metros, he said in his speech. In February 2014, ET reported, quoting Alstom, builder of France's TGV high-speed trains, that India is at least 10 years away from high-speed trains. India cannot just jump into the trains with average speed of above 350 km/h, before upgrading the trains to the average speeds from 80 to 120 km/h. Indian Trains does not have a good track record in average speed, though trains have maximum operating speed of 130 to 150 km/h. It is extremely important to upgrade the existing infrastructure. You should move from 60 to 70 to 80 and 100 to 120, and then in some corridors you could imagine running bullet trains, Bhupat Lafarge said in an interview to ET. As of now, increasing the maximum speed of trains to 160 to 200 km/h, average 110-120 km/h, have remained part of budget speech, without any long-term strategy or operational project has been announced and nothing else has been concretely done. In July 2014, a trial run of a semi-high-speed train with 10 coaches and 2 generators touched the highest speed of 160 km/h between New Delhi and Agra. Railways plan to introduce such trains commercially from November 2014. Approach to high speed. Indian Railways' approach to high speed is incremental improvement on existing conventional lines for up to 160 km/h, with a forward vision of speed above 200 km/h on new tracks with state-of-the-art technology, such as Shinkansen. While they do not define high speed, Indian Railways' approach matches the high-speed definitions of the Trans-European High-Speed Rail Network, for upgraded lines and new lines built for high speed. Dedicate tracks to passenger trains. Dedicate tracks on existing trunk lines to passenger trains, by building separate corridors for freight trains, and build separate tracks for busy suburban traffic in Mumbai and other cities where traffic is equally busy. Without slower freight and suburban traffic, fast express trains can run at the speed limit of rolling stock, the railway track or railroad switch, whichever is lowest among those that apply. Upgrade tracks for 250 euro 300 km/h. Upgrade the dedicated passenger tracks with heavier rails, and build the tracks to a close tolerance geometry fit for 250 euro 300 km/h. This implied that the high-speed gauges 5AFTA6 are an Indian gauge. High-speed tracks to be maintained and inspected using automation to ensure required track geometry. Perform more frequent inspection to ensure high confidence of safety at high speed. Design, manufacture and deploy railroad switches, with thick web construction and movable crossings that permit 50 km/h to alleviate this bottleneck to speed. Upgrade locomotives and coaches, improve coaches, which can support 160 km/h, with stainless steel bodies and crash-worthy designs, incorporating passenger and crew protection, and fire-retardant materials. Equip coaches with electro-pneumatic brake systems to enhance safe operations at 160 euro 200 km/h. Develop locomotives with output of 9,000 to 12,000 HP for hauling of 24 to 26 coach-long passenger trains to 160 euro 200 km/h. Indian Railways has asked IIT Kharagpur to conduct research to obtain the technological know-how to increase the maximum attainable speed to 200 km/h. The project, which will be conducted in the Railway Research Centre of IIT Kharagpur, has 4 main goals: improving speed, improving carrying capacity, use of advanced material, advanced signalling and maintenance for better safety. The research is expected to be completed by the end of 2015. Current semi-high-speed systems. Currently there are no semi-high-speed rail routes in India. A trail run has been successfully completed on Delhi-Agra section and plans are to start these trains on Delhi, Bhopal/Chandigarh/Kanpur/Lucknow sections after starting on Delhi-Agra section. The Delhi-Agra semi-high-speed train is expected to start from November 2014. Mumbai-Rajdhani Express will be upgraded to 200 kmph. This will reduce 8 hours of travelling time. According to Rail Budget 2014, Railway Minister Mr. D.V. Sadanand Gowda mentioned in his speech that railways are going to start high-speed trains at 160 to 200 kmph on 9 routes. They are: green background for the systems that are under construction, blue background for the systems that are currently in planning. Proposal to introduce 300-350 km/h trains. History. One of the first proposals to introduce high-speed trains in India was mooted in the mid-1980s by then Railway Minister Madhav Rao Scindia. A high-speed rail line between Delhi and Kanpur via Agra was proposed. An internal study found the proposal not to be viable at that time due to the high cost of construction and inability of travelling passengers to bear much higher fares than those for normal trains. The railways instead introduced Shatabdi trains which ran at 130 km/h. The Indian Ministry of Railways White Paper Vision 2020, submitted to Indian Parliament on December 18, 2009, envisages the implementation of regional high-speed rail projects to provide services at 250 euro 350 km/h, and planning for corridors connecting commercial, tourist and pilgrimage hubs. 6 corridors have already been identified for technical studies on setting up of high-speed rail corridors: Dil Chandigarh Amritsar, Pune Mumbai Ahmedabad, Hyderabad Kazipet Dornakal Vijayawada Chennai, Howrah Haldia, Chennai Bangalore Coimbatore Ernakulam Thiruvananthapuram, Delhi Agra Lucknow Varanasi Patna. These high-speed rail corridors will be built as elevated corridors in keeping with the pattern of habitation and the constraint of land. Indian Railways set up a corporation called High Speed Rail Corporation of India Limited on July 25, 2012, that will exclusively deal with the proposed high-speed rail corridor projects. The corporation is a wholly owned subsidiary of Rail Vikas Nigam Limited, a special-purpose vehicle that carries out the construction works for Indian Railways. It will handle tendering, pre-feasibility studies, awarding contracts and execution of the projects. The corporation will comprise 4 members, all of whom will be railway officials. All high-speed rail lines will be implemented through PPP mode on a design, build, finance, operate and transfer basis. The corporation was officially formed on October 29, 2013. The HSRC will coexist with the High Speed Rail Authority of India. The latter will determine the framework and the scope of works needed for India's high-speed railway plans, while the former will execute these decisions. Indian government has not taken any decision on building the high-speed rail in India. India is still guarded in its view on HSR. India will plan such projects based on its infrastructure priorities, commercial viability and financial resources in India. But it is expected that by 2030 to 2035 India will have its first HSR line ready, if not operational. The joint feasibility study for Mumbai-Ahmedabad route should be completed by July 2015. If approved, it will result in financial closure, land acquisition and resulting court cases, planning, engineering and construction. Cost. Feasibility studies. In a feasibility study published in 1987, RDSO and JICA estimated the construction cost to be Rs 49 million per km, for a line dedicated to €250 300 km/h trains. In 2010, that 1987 estimated cost, inflated at 10% a year, would be Rs 439 million per km. RITES is currently performing a feasibility study. According to news media, the costs for constructing such rail lines in India are estimated to be Rs 700-1000 million per km. Therefore the Mumbai-Ahmedabad route of 500 km, will cost Rs 370 billion to build, and to make a profit, passengers will have to be charged Rs 5 per km. Delhi to Amritsar one-way, a distance of 450 km, will cost about Rs 2,000. At $15-22 million per km, cost estimates are in line with $18 million per km of the recently completed Wuguang HSR line in China. The Mumbai-Ahmedabad line is slated to cost Rs 650 billion. Land acquisition cost has trebled after the new Land Acquisition Act passed by the government. High-speed rail may remain in the drawing board itself, because of this law, as suddenly land acquisition is costing 3 times more for all kind of infrastructure projects. Integrated infrastructure development. India's Indian National Expressway Network Plan matches with the HSR Network Plan. Both INEN and HSR can be built on the same alignment to cut the cost of civil construction. Machinery and automation. Indian railway construction as of today is mostly dependent on manual labour. If government announces a long-term railway construction policy, then private and public railway construction companies can buy automated railway construction machineries to bring down the cost. At present, it takes approximately 10 days a year besides nearly 3,000 labourers a year to lay a kilometre of railway track through the use of semi-mechanised methods. But, a stretch in the dedicated freight corridor constructed by private consortium used imported mechanised track-laying machines. The machine has the capability of linking 1.5 kilometers of track length in a day with very minimal manpower. But, it was imported at the cost of 70 Cr. So Indian railway and infrastructure financing companies have to invest heavily to reduce manual labour and automate railway construction in India. Routes. In India, trains in the future with top speeds of 300 euro 350 km/h. Are envisaged to run on elevated corridors, to prevent trespassing by animals and people. This is an excellent way to isolate high-speed train tracks. The TGV tracks are completely fenced in and has no road crossing them at the same level. Wuguang Euro unregistered trademark S2 tracks line is laid, 468 km on bridges, 177 km in tunnels, and 323 km on embankments. The 336 km THSR tracks are 91% on bridges, flyover, or tunnels. The current conventional lines between Amritsar New Delhi and Ahmedabad Mumbai runs through suburban and rural areas, which are flat, therefore have no tunnel. Ahmedabad Mumbai line runs near the coast, therefore have more bridges, and parts of it are in backwaters or forest. The 1987 RDSO-JICA feasibility study found the Mumbai-Ahmedabad line is most promising. Maharashtra state government has proposed a link between Mumbai and Nagpur which will be good for development of the state railway. The government also wants a corridor which will connect to Navi Mumbai International Airport. Potential readership. Current ticket price. As of July 2010, there are currently 49 train services with fares from $A70-115, or $A0.07-0.12 per km. Amritsar New Delhi line has 22 daily services, with fares range from RSA 552-1434. Ahmedabad Mumbai has 32 daily services with fares from RSA 514-1475. On the two Indian lines travelling cost RSA 1.14-3.19 per km. Growth of India's middle class. India has growing population and millions of people moving out of poverty into middle class every year. Current railway network is overbooked almost all of the time. Waiting lists appears instantly as bookings are opened. There is more demand than the supply for railway tickets. The question is how railways will bring down the cost of ticket in HSR to make HSR self-sufficient volume-driven business by having more seats in each train compared to other subsidized HSR networks in the world. Location of the HSR station. Location of the railway station will also play an important part in success of HSR. A railway station outside the city limit will have less patronage than the underground railway station in city centre with underground high-speed railway lines within city limits. For example, airports would have more travellers if they did not have 30 kilometres travel from the city centre in both originating and destination city. If HSR in Mumbai starts from CST will have more people using it than if it starts from Thane. Integration with the public transport of the town city with HSR, accessibility to daily commute as well as the distance of the stations from the CBD, location of all the stations in the route, total time of travel for short distance travel and potential for one-day business travel all will affect the number of people using HSR. Many HSR proposals world over have been rejected or have to be dependent on the government subsidies, because they could not replace ordinary rail as door-to-door travel times would be similar, with stations away from the current railway and public transport system. An integrated transport hub with multi-level stations for HSR, ordinary rail, metro, monorail and the public transport bus service would have ripple effect on the patronage of HSR as the accessibility is key to usage of costlier service. High-end bus traffic and paying capacity. South India has India-Euro unregistered trademark's highest growth rate and large economy states with GSDP above 15% compared to India-Euro unregistered trademark's GDP of 6%. This part of India may be the best location to have high-speed trains running profitably in the initial phase. Southern states have a multi-axle jerk-free Mercedes-Benz and Volvo buses running between cities with good patronage. Tickets costs upward of Rs 1,000. Still buses have full bookings. This population can be migrated to HSR if the rail starts from the center of the city. Fear of unknown. HSR in the initial months needs to heavily subsidize so that people can experience it. When air-conditioned Volvo buses were introduced for public transport in Bangalore, there were not many takers and buses were running empty. BMTC then decided to lower the prices to a level competitive to ordinary buses. This became an instant hit as word-of-mouth marketing of comfort of travel spread like wildfire. Today Bangalore has India-Euro unregistered trademark's biggest air-conditioned low-floor Volvo fleet for public transport with a large order in pipeline. Cross-subsidization in Indian Railways. Indian Railway Tariff Authority is expected to increase the patronage of high-end rail, as cross-subsidization between passenger and freight traffic may come down. Inflation of diesel prices versus stable electricity prices. Super-speed high-speed will become operational beyond year 2030. Since most of the Indian Railway is still on diesel, compared to the stable or decreasing cost of the electricity, by 2030 the ticket cost will become economical compared to the diesel trains. Suburban Regional Rapid Transport Airport High-Speed Rail Link Commuter Railway running on the high-speed railway lines. Optimal use of railway lines can be achieved by creating a regional rapid railway system on the HSR system, with separate platforms in the stations. Project execution. A separate entity, High Speed Rail Authority of India, has been set up to operationalize bullet trains in the country as part of 12th Five-Year Plan. To put the construction in perspective, In the period 2005 September, Indian Railways took on construction of 42 completely new conventional lines, a total of 4060 km at a cost of Rs 167 billion, or Rs 41 million per km. A public-private partnership mode of investment and execution is envisaged for such expensive €250 350 km/h high-speed rail project. Feasibility studies. Multiple pre-feasibility and feasibility studies have been done or in progress. The consultants for pre-feasibility study for 4 corridors are Sistra, Atulf and Wright Limited for Pune Mumbai Ahmedabad, British firm Mott MacDonald for Delhi Agra Lucknow Varanasi Patna, INECO, Pointc, AISA for Howrah Haldia, Japan External Trade Organization and Oriental Consultancy along with Parsons Brinker of India for Hyderabad Dornakal Vijayawada Chennai. During the 2012 rail budget speech, Railway Minister Dinesh Trivedi announced that pre-feasibility studies on the Ahmedabad Mumbai Pune, Delhi Agra Lucknow Varanasi Patna, Howrah Haldia, Hyderabad Dornakal Vijayawada Chennai and the Chennai Bangalore Coimbatore Ernakulam Thiruvananthapuram high-speed corridors have already been completed, and study on Delhi Jaipur Ajmer Jodhpur route will be taken up in 2012-13. In February 2013, Gujarat Chief Minister Narendra Modi demanded Railway Ministry for speedy implementation of pending high-speed rail projects in the country. In September 2013, an agreement was signed in New Delhi to complete a feasibility study of high-speed rail between Ahmedabad and Mumbai, within 18 months. The study will cost yen500 million and the cost will be shared 50-50 by Japan and India. High Speed Rail Corporation has called for international bidders for carrying out the pre-feasibility study of the 450-kilometre Delhi, Chandigarh, Amritsar high-speed corridor. Non-standardization of high-speed rail infrastructure. India has not standardized the infrastructure for high-speed rail projects to be executed across India. This has resulted in different projects using different gauges for their lines. Delay in standardization may result in using inefficient use of high-speed route for freight transport, as the both standard railway and high-speed railway are using different kind of gauges. Delay in creating a standardization for high-speed railway in India may result in a project like Project Unna Gauge, which may be necessary as control of PPP projects are given back to the Indian Railway by concessionaire after the concession period. Standardization will make Indian railways more efficient, avoid the current break of gauges, increase the freight carrying capacity and shorten the routes with many re-gauged links. It will also standardize the manufacturing of railway components across India, thus bringing cost of manufacturing of the indigenous railway-related components. Using a broad gauge is expected to bring down the cost of transporting freight from one place to another and necessary to keep trains stable in the face of strong monsoon winds. Broad gauge allows bigger trains, higher speeds, and more stability. The con is cost, it costs more than smaller gauge. Fragmentation of the high-speed rail network. There are two kinds of fragmentation which can be seen in the high-speed rail network in India. There is no single government agency which will own the stretch. There is also different gauges used by different projects, and India has not defined its own standard for its HSR, like China, using which it can bring in competition among the bidders and induce technology transfers. In India, national highways are being developed under BOOT basis. NHAI is the sole authority which will have the control of all the national highways at end of concession period. But, high-speed rail network development in India is fragmented. There will not be end-to-end ownership or leasing out of the HSR in India. So, there can be no single Indian government agency owning the complete HSR network in India. Unlike NHDP, where the national highways will come under the direct ownership of the central agency National Highway Authority of India, after the end of concession period, high-speed rail development is still driven by multiple independent companies. This means high-speed railway infrastructure will remain fragmented across India, without any company controlling end-to-end railway line from east to west or north to south, for unforeseeable future. For example, alongside Arabian Sea coast, Kerala High Speed Rail Corporation Limited is driving a standard gauge high-speed rail, whereas Indian Railway is working on broad gauge, for Ahmedabad-Mumbai corridor. Speed of trains. High-speed railway projects are still in planning stage, and when the HSR is constructed and becomes operational, the best available technology at that time will be adopted. Adopting high-speed trains will reduce the fuel consumption of the country, reduce time cost, provide major boost to manufacturing, services and the agriculture sectors, save foreign exchange by transporting large amounts of people and goods in a shorter time using less inflationary electrical power instead of imported fossil fuels. India is mainly working with Japan and France for the high-speed trains. In 1969, the Rajdhani Express was introduced with speeds up to 140 km/h, a great achievement at the time. The top speed has remained almost the same for 45 years. As of Interim Railway Budget 2014-15, no long-term strategic and concrete policy measures have been taken regarding trains above the average speed of €70–90 km/h, Shatabdi, Rajdhani and Duronto, trains. As of 2014, Indian Railway network does not provide any significant benefit over the road transport. Railway infrastructure is unable to compete with the accessibility, last-mile connectivity and door-to-door travel time of 120 km/h designed expressways. Looking at current speed of implementation in DFC and other railway projects, first line of high-speed train may become operational by 2030 to 2035, and the subsequent lines becoming operational between 2030 to 2060 timeframe. This can happen only if government commits enough resources for the implementation of the same, as economic and manufacturing stimulation package. As of 2014, high-speed rail is still in consultation and discussion stage. High-speed freight train, optimal use of the high-speed railway network and for the economic development of the country, it is expected that freight trains will use the high-speed network. HSR network cannot break even with just the passenger traffic. Freight trains needs to run on these lines to make them profitable. It may be a road-rail synergy system or a container traffic. Freight trains result in efficient use of the tracks, especially in the night time. JIT and reduction of the inventory is possible with HSR freight trains and overall productivity improvement. However, a Scandinavian plan about HSR between Oslo and Copenhagen reports that costs of high-speed lines with freight train capability is significantly higher than pure high-speed lines. Diamond Quadrilateral Project. Introducing the Diamond Quadrilateral high-speed network connecting the four major cities of India located in four edges of the country was a key plank in the BJP's election manifesto, and the BJP government has shown interest in implementing the project. After winning the elections, prior to taking office, three top officials from Indian Railways were instructed by then PM-designate, Narendra Modi to carry out a reconnaissance mission with France's state rail operator, SNCF. In his address to the joint session of the Parliament, on June 9, 2014, the President of India, officially mentioned about the policy of the new government led by Narendra Modi to launch a Diamond Quadrilateral project of high-speed trains. Legal. No new Act of Parliament or Parliament-approved policy measures has been planned for the high-speed railway in India. It is expected that Railways Act, 1989 along with Ministry of Railway will be guiding the implementation of the high-speed railway in India. Government authorities, High-Speed Rail Corporation, this has been set up to evaluate ways to implement high-speed train projects in India. HSRC will be under Rail Vikas Nigam Limited and will be an institution that will do ground-level work. HSRC would undertake project activities such as preparation of project-related studies and technical standards high-speed rail corridors. High-Speed Rail Authority, this is a planned high-speed rail regulatory authority. HSRA will be under the Ministry of Railways to form standards on ticketing, tracks, rolling stock. HSRA is a medium to set technology standard. High-Speed Rail Authority as a regulatory body which will supervise administrative, institutional, and financial issues. Research Design and Standards Organization, RDSO will help to set up standards, before the HSRA takes over from it. R&D institutions, Centre for Railways Research, IIT Kharagpur. Research Designs and Standards Organization, India does not have indigenous the high-speed or super-speed railway technology. It is currently dependent on other countries. Narendra Modi, the Prime Minister, has promised to build 4 railway universities, so that India can be world leader in high-speed railway. Manufacturing base, Bombardier India, Alstom India, possible cultural and economic effects, Yoshiyuki Kasai, chairman of the Central Japan Railway Company, India does not have the choice but to build the high-speed railway system achieve higher growth rate. High-speed railways makes travel time between cities shorter by several hours. Due to this, different cities are integrated into a single economic life zone. The long-term economic and social impact of such systems will be huge. India's transition to world's back office has helped only the educated and skilled youth of the country. India needs to change itself into world's manufacturer to provide job opportunities to the biggest youth population in the world. India is in an advantaged position to take up the leadership position in manufacturing at the cost of China for the next 20–30 years, because of India's demographic dividend which is available for next 20 years or so, before it turns into demographic liability. But, India has plains in interior of India where it can set up large-scale manufacturing bases without causing much environmental degradation. India needs to build infrastructure to connect interior of India to seaports through mega infrastructure projects. High-speed rail is one of such projects which can accelerate India's growth rate. India Euro unregistered trademark S double-digit GDP growth. A Euro OE investment Silea Euro created by the high-speed rail will result in India making a major jump to the double-digit growth rate. Indian economy will be converted from social sector-focused expenditure-based economy with Euro 5% growth rate and low-value jobs to the investment-based double-digit growth rate economy with high-value jobs, helping India to effectively use the demographic dividend for next 30 years, before it turns into a demographic liability without major pension reforms. Job generation, micro, small, medium and large-scale industries will benefit by the HSR. A company manufacturing nut and bolts to the company working on high-tech steel will all get benefited, taking India's manufacturing share to 25% of the GDP. It all depends on the government. A Euro unregistered trademark S domestic content, technology transfer and competitive bidding policies. High technology research, HSR implementation is going to open high technology research in multiple areas of science and technology. Whenever India wanted to pursue such technologies there were criticisms saying India cannot afford it. But, investments in space, nuclear, satellite communication, ocean technology have helped India in many different areas. India will lose diversity. India had multiple cultures and language, as the rivers, mountains and forests had separated the people-to-people contact, helping local cultures to prosper. HSR will change that as India will move to a single identity and culture, which may emerge as time passes. Railways will gain against the road and airlines. Railways will become major mode of transport with unmatchable door-to-door travel time compared to airlines, standard train and bus. As 1 day of travel is converted into 1 hour, it will compel people to dump bus, cab and car-based group travel to HSR. Airlines and airports will close down. HSR in Taiwan has resulted in many small airlines and regional airports closing down, as most of the travelers shifted to the HSR. Cheapest production cost for goods, long-distance travel will move away from petroleum-based inflationary fuel to the electricity, whose real cost of production is decreasing and is non-inflationary, as India is one of the biggest producer of renewable energy in the world. Emergence of ghost towns, migration may accelerate, if towns of interior India are not provided with job opportunities and facilities matching available in major towns. Forceful investments in middle part of India which has a large distance from seaports may be way to avoid it. Towns or cities which use economy based on the bus and truck travel as resting place, they will lose business. Straw effect, south and west of India will attract best talents from across India for NMIZs, EPIPs, IT parks, ITIRs, SEZs, DFCs, Biotech Park, ESDM Park, Textile Park, Aero Park, gem and jewelry park, financial districts, expressways, seaports and industrial towns. Education institutes in South will make sure that people leave their home early in their teens, as seen after 1990s. Tourism and other services sectors growth, access to NE and Kashmir will be hours of travel from days. Foreign and domestic tourists can cover more places in the same time, thus bringing wealth to more places. Tourism may emerge as a major source of income, if enabling environment is created. Religious tourism, temples will become accessible in 1 hour from current one-night journeys. This may have major inconvenience for the common people and free darshan, which may result in a 2-day waiting period from the current 1 day in places like Tirupati and Sharadi, as there will be more special darshan devotees, as seen in the recent years after the highways have become better. Conquering of world railways by India. Euro investment in a sector will result in genesis of companies with unmatchable know-how and money power, which go on to acquire companies and invest in sector across the world. India Euro unregistered trademark S investment in airports, space, petroleum, telecommunication, renewable energy etc. have created companies, mainly in private sector, which have gone international and acquired companies worldwide. GMR, GVK, Airtel, Indian Oil, ISRO, ONGC Videsh, Sislan. India's investment in space with missions to Mars, Moon and largest constellation of remote sensing satellites have stimulated the manufacturing sector, with large order pipeline for outsourced satellite launch. China Euro unregistered trademark S. China Euro unregistered trademark SCS. A corporation and China CNR Corporation have helped China to spread its soft power across the world. Poverty alleviation, India Euro unregistered trademark S. Expenditure-based poverty alleviation has been a failure against the investment-based growth. Highest GDP through job generation against the one-time subsidy payouts have helped India to uplift record number of people out of poverty, year after year. As seen in Japan, HSR lines bring along with them investment and prosperity. Manufacturing and alternative to China. Euro India may become a major manufacturing hub as the interior of India with barren land can connect with seaports, which are surrounded by greenery. It is difficult to set up industries in the green zone, but interior India has enough land to set up NMIZs. Rail diplomacy. Euro-China has effectively used HSR to build relationships with neighboring countries by building deep tunnels to build the economic corridors through mountains. Agriculture sector growth, perishable goods can be transferred from one place to another, cutting down the wastage. Reduction in greenhouse gas emission, indirect benefits outweigh the direct benefits in high-speed railway. India will save crores of rupees in import bill as railway network of India will be migrated to electricity from the current diesel trains. See also, Dedicated Freight Corridor Corporation of India, external links. Official website of High Speed Rail Corporation India Limited, references.